Let me ask you something. Why is aviation the safest form of transportation in the world, even though it looks the most dangerous? Think about it. We fly at 35,000 feet. We travel at 500 miles per hour. We operate in bad weather. We share airspace with hundreds of other aircraft. And yet, commercial aviation accident rates are extraordinarily low. How is that possible? Is it luck? Is it because pilots are superhuman? Or is it something else? Here's the truth. Aviation is inherently high risk. What makes it safe is not the absence of risk. It's how we manage it. Risk is natural. Safety is engineered. And if you understand that early in your career, you will think differently than most people in aviation. So let's define it properly. According to the International Civil Aviation Organization, safety is the state in which risks associated with aviation activities are reduced and controlled to an acceptable level. Reduced and controlled, not eliminated, controlled. Safety does not mean zero accidents. If someone tells you aviation safety means no risk, they don't understand aviation. Zero risk is impossible. Aircraft operate in physics. Weather exists. Humans make decisions. Machines fail. So if zero risk is impossible, what does acceptable level mean? Who decides what is acceptable? Regulators like the FAA, international organizations, industry performance targets, accident data, historical analysis. Safety in aviation is performance-based. We measure it, we track it, we improve it. So if I ask you, define aviation safety, you should be able to say, aviation safety is the condition where risks are identified, reduced, and controlled to an acceptable level, not eliminated. That distinction matters. Now let's go deeper. Before we can manage risk, we need to understand something else. What is a hazard? Think about that for a second. Is turbulence a hazard? Is pilot fatigue a hazard? Is an accident a hazard? Here's the definition. A hazard is a condition, object, activity, or event with the potential to cause harm. Notice what it says. Potential. A hazard is not the accident. A thunderstorm is a hazard. An engine failure is a hazard. Runway contamination is a hazard. Fatigue is a hazard. A maintenance error is a hazard. A TC miscommunication is a hazard. But none of those automatically mean an accident will happen. They are sources of potential harm. That distinction is critical. Let me give you a real-world example. I've flown in severe weather environments. A thunderstorm by itself does not cause an accident. Flying into it without proper planning, that's when risk increases. The hazard exists whether you acknowledge it or not. Professional aviation means identifying hazards before they escalate. So if I give you a scenario, an aircraft departs with a fatigued crew after multiple delays in deteriorating weather, I might ask you, what are the hazards? And you should be able to identify fatigue, weather, operational pressure, not the crash. Because hazard is the source. Risk comes next. And that's where we go in the next section. All right. We've defined safety. We've defined hazard. We've defined risk. So now let me ask you something. If hazards exist, and risk is measurable, what do professionals do? Ignore it? Hope it goes away? Or manage it? Aviation does not operate on hope. Aviation operates on risk management, and the process is simpler than you think. 3 steps. Identify the hazard. Assess the risk. Mitigate the risk. That's it. But the discipline is in how seriously you do it. Let's walk through it like professionals. Step 1. Identify the hazard. You can't manage what you refuse to see. Weather on the route. Crew fatigue. Short runway. Maintenance write-up. Operational pressure. The hazard is there whether you acknowledge it or not. Step 2. Assess the risk. Now we ask, how likely is this? If it happens, how severe will it be? That's probability and severity. If I'm planning a flight and thunderstorms are forecast along my route, I don't ask, will I crash? I ask, how likely is convective activity? If I encounter it, how severe are the consequences? That's professional thinking. Step 3, mitigate. This is where aviation becomes engineered. We introduce defenses. And here's the key. Mitigation does not remove the hazard. It reduces exposure or consequence. That is mature safety thinking. Let me give you real examples. Weather radar. Does radar eliminate thunderstorms? No. It allows you to avoid them. That reduces exposure. Standard operating procedures. Do SOPs eliminate human error? No. They reduce variability. Training. Does training eliminate mistakes? No. It reduces probability. Redundancy. Multiple hydraulic systems. Multiple electrical buses. Redundancy doesn't eliminate failure. It reduces severity. This is exactly how aviation became safe. Layered defenses, structured mitigation, disciplined assessment. So if I ask you, describe the 3 steps of risk management, you should say, identify hazard, assess likelihood and severity, mitigate through defenses. And if I ask, does mitigation eliminate hazard? The correct answer is no. Hazards remain present. We manage them. That's professionalism. Now let's elevate this. Let me ask you something uncomfortable. When an accident happens, what does the media say? Pilot error. Is aviation safety that simple? No, because aviation is a system, and a system, as defined in safety doctrine, is an organized, interdependent structure of elements working together. Interdependent, meaning no one operates alone. Let's break that down. The mechanic signs off the aircraft. The dispatcher releases the flight. Air traffic control provides separation. The pilot executes. Management allocates resources. Training departments shape competence. Every one of those decisions influences safety. If a mechanic feels pressured to rush, that affects airworthiness. If dispatch underestimates weather risk, that affects exposure. If management cuts training time, that affects probability. So when we talk about safety, we're not talking about a department. We're not talking about one checklist. We're not talking about one regulation. We are talking about a complex, interdependent system. And here's the reality. You are entering that system. Whether you become a pilot, mechanic, controller, safety analyst, or manager, you are a safety variable. Your decisions alter probability. Your discipline alters severity. Your professionalism strengthens or weakens defenses. That's why aviation is safe. Not because risk disappeared, but because thousands of professionals manage it every day. Safety is engineered. Risk is measurable. Hazards are identifiable. Mitigation is structured. And responsibility is shared. If you understand that in your first year, you're already thinking like a professional,